In this scale, the frequency of each C note in vibrations per second is measured in hertz. It can be expressed as a power of 2 as shown. What is the frequency of the note C7 in exponential form and in logarithmic form? Okay, take a look at the photo to better understand what's being asked here. So we're shown middle C, and we're told that it vibrates at 256 hertz. C5 is 512 hertz, and C6 is 1024 hertz. And we're told that to go from one to the next, these are being doubled. So for example, 256 times 2 gives us 512. 512 times 2 gives us 1024. So what are we being asked? We're being asked what the frequency of the note C7 in exponential form and logarithmic form is. So C7 is not actually shown to us on this chart, but we have some ideas of how we can get there. First of all, because we know that the notes are being doubled from one to the next, we know that to get the hertz for C7, we'll simply have to double what we have for C6. A few other things to consider. They tell us that these numbers can be written as powers of 2. Remember that power of 2 means numbers are multiplied by 2 every time. So for example, 2 to the first is 2, 2 to the second power is 4, 2 to the third is 8, and so on. And each time, I'm just multiplying by 2 another time. So what would my exponent have to be to get to 256? 2 to the what equals 256, right? And 2 to the what equals 512, and so on. Again, if C6 is 1024, we have to double those hertz to get to C7. So what is C7 going to be? Now, because we know enough about logarithms and exponents, we can rewrite C6 as 2 to the x equals 1024. We have our base, we don't know the exponent, and we have the result. Okay. How could we write C7? So C7 would be 2 to the something equals that doubled number. And how would we rewrite that in logarithmic form? So there are two ways you can approach this. You can continue on as I've written my 2 to the first, 2 to the second, and so on. I could just keep doubling until I get to the numbers I want, but that might take me a while, right? So the better way, the more efficient way, is to use what you know about logarithms and exponents to solve for this x in C6. Once you have that, it'll be easier to solve for C7 and rewrite it both in exponential and in logarithmic form. Next, we're told if the frequency of a note C is 32 vibrations per second, how many octaves higher or lower than middle C is this note? Okay, so we are being asked to solve how many octaves, so we're going to have a number of octaves as our answer. And we know we're comparing to middle C, so let's keep our eye on that. We're told that this new frequency, C something, is equal to 32 vibrations per second, 32 hertz. So how many octaves higher or lower than middle C is this note? Well, let's write it out in exponential form. So 2 to some power equals 32. For middle C, 2 to some power equals 256. So solve for x in both cases and compare. Take the difference of them. And what can you say about C compared to middle C? Well, you'll be able to tell the number of octaves difference. The number of octaves higher or lower will be equal to the difference between this x and that x. For example, if I was comparing 2 to the first, which is equal to 2, and 2 to the second, which is equal to 4, and I wanted to compare the exponents, 2 minus 1 is 1. That's my difference. You're doing the same thing here. Okay, so fill in the information, solve for x for each, compare the x's, and you'll be able to answer how many octaves higher or lower the middle C is. The higher or lower part, notice that as the hertz double and grow in size, our notes are going octaves up. As our numbers shrink in size, our octaves are getting lower.